One of the major concerns these days is that the United States stock market has meltdown for 4 times in the past 20 days. This is really astonishing since this has only happened once in the whole history of American stock markets. As a result, we want to learn about it. We decided to apply deep learning to this problem, and we're going to train a model using the past history data of an index fund to predict whether the value of this index fund will increase or decrease in the coming day. The result from our prediction is simply a bidirectional variable. So it's whether we should invest it or not invest it. If the result is we should invest it, it means the stock value will increase tomorrow, and vice versa. We all know it's pretty hard to select the appropriate feature for training this model, since a lot of factors could potentially affect the trend of the stock. As a result, we read several papers and came up with a list of features that we think can accurately predict the trend of the model. So there are 3 categories in total. What's the first one is the regular stats, like the closing price and open price, high price and low price, and volume. The second is some index that is correlated with the index fund itself. For instance, the US dollar index and the federal fund rates. The third one is other factors index. For instance, MACD, CCI, WAD. This index basically related. They're related to different parts of the life. For instance, the panic index, something like that. And we think this index could train a good model that can make a correct prediction.
The next step after feature selection is pre-processing in our project. And there are mainly 2 sections. The first one is scaling. Because we have many features and the feature space is high dimension, we want to expedite the training process when we have large amount of data and a lot of features. So we need to do scaling to make them into a similar range. In class, we have learned that z-score normalization is a very popular and common method to do that and can ensure that the gradient descent is at a high efficiency. However, we didn't choose that because we think about it, the training data and the testing data in our case can be in a very different range. So when we're doing normalization, only using the training data mean and standard deviation, maybe it's not very appropriate. So with that thought, we also read more papers and we learned that another method is to scale by a constant factor for each different feature. So we use this way and we time the feature with a different constant factor to make all of them in the range between 0 and the 10 in terms of absolute values. And the second part is denoising. And the method we choose is wavelet because we also see several papers that use it as the way to denoise financial data because it's specifically very appropriate in this case. Wavelet, one of the key properties that it can analyze the frequency components of the financial time series with time simultaneously compared with the Fourier transform. So this is why we choose to use wavelet to do the denoising before we start to train the model. Here's the graph that compares one of the features we have before and after the wavelet transformation. And as we can see that the orange line, which indicates the data after the wavelet transformation, has much less noise compared to the blue original line. The next step we did after pre-processing is choosing what deep learning models we want to use. Usually in most of papers, one deep learning model is chosen to train the data and do the prediction after data processing. But we decided to involve 2 of them because there are papers which use 2 and we want to try how that could help our prediction results. So the first one we use is a stacked autoencoder. Usually stacked autoencoder is used in image processing for denoising and also for dimension reduction. But in our case, that because we don't have that many features, so we don't want to use it for reduced dimension. Mainly we want to use it for learning the financial time series in an unsupervised manner first before we do supervised learning with another model. So that's why we used it. The second model we used to learn the historical data using a supervised manner is LSTM. And we use that because firstly, it's widely used in papers that try to predict financial prices. And the second thing is that LSTM, it doesn't have the gradient vanishing problem when the time series data is very long, and actually be able to memorize a short-term feature and long-term feature at the same time. So that's why we decided to use LSTM as a second model. So here is a scatter plot for our results. The orange dots are the true values, and the blue dots are the predicted values. This is just part of the time, like we chose 150 days to show this graph. But as we can see, there's a big problem because the predicted values are always around kind of very close to the mean of the true values, and it's always in a small range, doesn't change. So this indicates that there's a problem in our model. So after figuring out that there's a problem in our prediction scheme, we decided to start failure analysis and try to debug and fix this problem. Because we find that the data after pre-processing definitely doesn't have a problem. So we identified that the problem is either in stacked autoencoder or it's in LSTM. So what we did is that we completely removed the stacked autoencoder and see whether the LSTM can give a correct prediction pattern, but it doesn't. So we figure out that there's at least a problem in the LSTM model. So then we tried to see different examples online and try to fix the model we have. But after several days of work, we still didn't successfully fix this model. So we end up not having a model that can, like a scheme that can predict correctly, but we definitely learned a lot through this process. After failure analysis, although we didn't successfully fix our model, we still would like to learn more from our projects through reflections. There are mainly 3 points we have reflected on. The first one is that during pre-processing, we didn't use Z-score normalization because we are worried that the range of testing data and training data could be very different in this time series financial data. However, we also realize that if we are using small batches in our training process, each small batch, the data range will not be that different. So we can do Z-score normalization for each batch separately. And the second point is that for wavelet transformation, a problem that potentially could lead to is that the two consecutive data points now have less change between each other. So maybe there's the loss of pattern in that, and which can be discovered by deep learning. And the third thing is that we also, if the model do work, we would like to try whether the stacked autoencoder actually add value to it, and the number of layers, the parameters, and also the activation function we use in this stacked autoencoders. How do they affect the results of prediction if it actually has an effect? So that's what we want to learn more about, and this marks the end of our project. Thank you.